Now, in addition to the RL circuit, we can also have an RC circuit. So I'm going to draw it up here. Again, it's similar. Like this. And what we have there is we've got a capacitor down at the bottom there and no inductor in the circuit. So remember the E for the resistor was I times R, and the E for the capacitor was Q over C. So those are the two E's that we have, and then we have whatever E source we have here. So whatever that number is. And I'm going to go ahead and bring up some numbers here. I'm going to put in some example. And I'm going to let R equal 4,000 ohms. And I'm going to let the capacitance equal 200, what are called microfarads. And I'm going to say that my E here is 100. Now, what happens with an RC circuit is that this capacitance here is based on the amount of, or the voltage based on the capacitance is based on this Q as well. And Q, the charges don't get there immediately. If you think about this, if you had a closed switch and you had an open switch, you close the switch, charges start to run, but there's some time before this is able to get all the way charged. And so that is the time that it takes for those charges to accumulate. And so it turns out that the I that we have from right here is related to the number of charges. That's how rapidly the charges move as a function of time. Okay? Derivative of charge with respect to time. So our E would be equal to ER plus EC. E is 100. ER I times R plus Q over C. And now we look at that I and we say, well, what I is dQ dt. And we remember that we're in differential equations class because now we got a Q and a dQ. Okay, so now that's the equation that we want to kind of work with and put in these other values. R I have is 4,000, so that 100 equals 4,000 dQ dt plus Q over 200 microfarads. And we need to be a little bit careful with that. At 200 microfarads, 200 times 10 to the minus 6. I'm not happy terribly about that being, having a denominator anyway, but I don't need one. If I go 1 over that, 1 over 200 times 10 to the minus 6, that will give me 5,000. So that term right there, instead of being a fraction, can just be 5,000 cubed. And now we're back to right where we were with these other functions, where we say, well, now we need to be able to solve this, etc. What do? It's going to be an integrating factor. I'm going to go ahead and clean this up a little bit, divide by 100, and I'm going to move things around so that it fits what I was doing before too. I have 40 dQ dt plus 50 Q equals 1. And now, with that equation, I can say, all right, I want to find an integrating factor, but also I've got a factor in front of this dQ dt. What I really want is I want to say dQ dt plus divide by 40, I'd have 5/4. 5Q over 4 equals 1 over 40. That way, dQ dt is by itself. In all these equations that we've done, we had a clean derivative, and then it was whatever's in front of the other one. That's where our integrating factor came from. So my integrating factor here is no difference. The integrating factor is e to the integral of 5/4 dt, which of course becomes e to the 5t over 4. I do that multiplication, and as happens in every one of these cases, I've got e to the 5t over 4 dq dt plus 5q over 4 e to the 5t over 4. And we can see that those are, again, it's going to be a derivative product here. And on the right hand side, just e to the 5t over 4 over 40. So q e to the 5t over 4, this is the derivative of that product. And I separate variables. And I'm going to integrate both sides. The left side integrates to just this. The right side, I've got that 1 over 40. Again, you could do a substitution, say u is 5t over 4, du dt would then be 5/4, which means that dt, u dt is 5/4, then dt is 4/5 du. So we're going to get a 4/5 that shows up because of that, and then e to the 5t over 4. Of course, plus c. Of course, we now divide through by e to the 5t. Q equals, I can do some simplification here, that's going to be 1 over 50, I hope. E, and then divided by the e, that goes away, and I've got 1 over 50 plus c e to the minus 5t over 4. And again, if we think of an initial condition, well, what would the initial condition be here? Should be the amount of charge that's actually on the capacitor.